Circles, first you need to prepare all the theorems, right?
Yes, ma'am.
Okay, and then questions I am taking from circles. Can you tell me which chapter is circle? Anyone? Yes.
Chapter 9.
Okay, chapter 9. Yeah. We are having a circle. This angle is given as a 50 degree. And the question says in the given figure, if angle OAB is 40 degree, then angle ACB is what?
Ma'am, AOB or OAB?
OAB.
In the
Wait,
diagram, it's 50
wait just
degree.
a second. It says 40 and here it is written that 50. No, it is 40.
Ma'am, 50 degree.
Everyone is getting 50 degree.
Yes, ma'am.
Yes, it is 50 degree. And one more information is given. Yeah. Yes, it is 50 degree over here. Uh, First, here you can see, like everyone, have you done or shall I explain it?
Done.
Done. Yes, Afreen, Anam, and who is
Ma'am,
who
I've
else?
done it.
Sarah, have you done the first one?
Yes, ma'am.
Okay, do the next one.
Mama's angle ACB 85.
85. Everyone is getting 85. Yes, it is 85. Yes, the previous one is 85. Everyone has got the same.
Yes, ma'am.
Yes, Afreen. Uh, you only answered at first. Who has answered?
Anna.
Acha, you have answered. Yes, Afreen, Sarah, what you are getting the second one? Are you getting 85?
Yes,
Is
ma'am.
it? Here it is given that angle DAB, DAB, the complete angle is 50. Okay. And ABD, ABD, this much only is 45. Then we have to find angle ACB. ACB. Okay. Angle in the same segment are equal, right?
Yes, ma'am.
Right? Yes or no? This theorem is there, right? Yes or no?
Ma'am.
Okay. So you can focus on this triangle and you can find this angle by using angle sum property. Now, whatever will be this angle, angle C will be the same. Why? Because in a circle, if two angles you are getting in the same segment, in same segment, if you are having angles, okay, suppose you are having a chord like this. So this is a segment, this is another segment. And if two angles is getting created both in the same segment, both on the circumference, okay, and in the same segment, then both the angle will be equal, like this angle and this angle will be same, created by, you can see both the angle created by same arc and in the same segment. Yes or no?
Yes, ma'am.
Okay, so yeah, let's do the next one.
Ma'am, is the answer angle CBA?
45.
CAB, yeah, 45. Yes, everyone has got question number 3 as what was the answer? 45. Have you got the same?
Yes, ma'am.
Okay. See, for the previous one, yes, uh, Anam, you have answered. Afreen, have you done? Sarah, have you done question 3? Yes or no?
Yes, ma'am.
Okay. Sarah, have you done?
Yes, ma'am.
Okay, let me do the next one. Here the figure is not given. Yes, question number 4. Are you doing it? Just a second. Are you done with the previous one? Okay, we need to draw a figure over here. So if O is the center of a circle, let's draw it. A circle we are having. And O is the center of this circle. Okay, of radius is R, and AB is a chord. Anywhere we are drawing a chord AB. Okay, AB is a chord of a circle at a distance r by 2 from O. The distance of AB from O, that is r by 2. That means perpendicular distance. Are you getting it?
Yes, ma'am.
From a point on a line, okay, if you are having a line and if you are having a point, if you want to find the distance of this point from this line, then always we will be taking the perpendicular distance. You know that, right?
Yes, ma'am.
Okay, so this perpendicular distance is given r by 2. Now perpendicular on the chord, bisect the chord. That was one of the theorem, right?
Yes, ma'am.
Okay, so our chord is also getting bisected. We will keep in mind. And let's continue what exactly we have to answer. Angle BAO. Okay, let me draw over here. Let's see how can we find angle BAO. This is R, right?
Yes, ma'am.
Let's try finding AB. Okay, let's try finding AP first by using Pythagoras theorem. So hypotenuse square is equals to OP square plus AP square. Can we write it?
Yes, ma'am.
So R square minus R square by 4 is equals to AP square. AP square 4R square minus R square by 4 implies AP square is equals to 3R square by 4. Yes or no?
Yes, ma'am.
We have to find angle BAO. No? This angle we have to find. But will it help? Just a second. Let me check which property will help. Or I need to check the question as well. Have I written everything? These two angles will be same. Triangle AOB is an isosceles. Angle A, angle B will be same. Okay, I'm checking first. Let me check the question. Otherwise, we will keep on working and we will realize that the data I have not given properly. O is the center of center of a circle of radius r, and AB is a chord of a circle at a distance r by 2 from O. Then angle BAO. Yeah, actually this question, no, there is a way to solve it. Okay, your level concept we cannot use over here. Okay, there is a way to solve it, but you will not be getting the way. Here trigonometry concept we have to use, which is there in class 10. Okay, please do let me check this one as well. If a chord AB and CD intersect each other, there is a chord AB and there is a chord CD intersect each other at right angle, then x plus y. Then x plus y. Yeah. Here also angle in the same segment will work, right? Right?
Yes, ma'am.
Okay.
Is it x plus y coming out to be 90?
How you got it? Yes, Anam. How you got x plus y is a 90?
Since it says the AB, the chords AB and CD intersect at 90-degree angles
Hmm.
at a right angle, so angle UC by linear pair will also be 90 degrees, and angle ACO and angle OBD will be angle in the same segment, so they both will be equal.
Yeah.
And in triangle ACO, we can use the angle sum of triangle.
Yeah. Okay. If this is y, this will also be y. Yeah. Yes, everyone, you will be able to do it. This is not the question where we need to use some extra concept. Okay. You will be able to do it. Please try it. This is such a good question. And this type of question do come in exam. Okay, already I have added the hint. The main key point I have added over here, that is angle in the same segment. Okay, and this 90-degree will help you. Please try doing it. Yes, everyone, I am explaining this one, okay? The previous one, then I'll be drawing the figure of the next one. See, here, if this angle is 90-degree, this is 90-degree, then see, we are having a circle. Here, AB is there, okay? And if this much is 90, can we say this will also be 90? Yes or no?
Yes, ma'am.
Okay, now if you are understanding that we are having an arc, and the same arc is creating this angle and this angle. Can you see that?
Yes,
Yes
ma'am.
or no? So the angle in the same segment will be same. This angle over here and this angle over here will be same. If this is y, that will also be y, right?
Yes,
Okay, then can we see that this is x, this is y, by angle sum property in triangle ACO. Okay, x plus y plus 90 is equals to 180. Yes or no?
yes, ma'am.
And from there directly we are getting x plus y as a 90, right?
Yes, ma'am.
Got it, everyone?
Yes, ma'am.
Okay, this is how we'll be doing it. Let me draw the figure for this one. Sarah, Sarah, is it clear?
Yes, ma'am.
Yeah, please do it.
Ma'am, 3 centimeter. No, 2 centimeter.
Yes, it is
Yes,
true.
ma'am. 2 centimeter.
Okay, everyone getting the same? Yes or no? Just a second. Can you tell me how to prove this theorem? The theorem which I am showing just now. The angle subtended by an arc of a circle at the center is double the angle created by subtended by it on the remaining part of the circle. Anyone, can you tell me how to prove this theorem? Yeah. Yes, the theorem. How to prove this theorem? Angle subtended by an arc at the center will be double the angle subtended by it on the remaining part of the circle. See, this is quite different. In all the theorem, we are just doing the we are taking triangle and we will be proving congruent every time. But this was here what we were doing. We were taking one circle. Just a second. Here we were taking one circle. Okay, and suppose a specific arc is creating angle at the center and the same arc is creating angle on the circumference, then we have to show that this angle will be double of this angle, right? Then we will
Yes,
be
ma'am.
doing construction over here. We will be joining like this, and then we will take triangle. Which triangle? We can take this triangle at first, and we will say that exterior angle so form is equals to sum of opposite to interior angle. Yes or no?
Yes, ma'am.
Okay, so you can say that x is equals to y plus z. Similarly, for the other triangle also we can say that this part is equals to sum of opposite to interior. But one more thing we must notice over here, that the triangle which we are drawing, okay, this triangle, suppose the name is AOB, this triangle AOB, okay, this triangle AOB, it's an isosceles triangle. Can you see OB is the radius and OA is also the radius, right? Okay, so y and z are equal with each other, right?
Yes, ma'am.
Okay, so you can say both are z z. You can say both are just 2z. So x is 2z. Okay, similarly here, suppose you are saying k. So k will also be 2p. Can we say if angle is
Yes, ma'am.
Okay, x is 2z, k is 2p. X plus k is nothing but 2 times z plus p. Yes or no? Is it clear?
Yes, ma'am.
You don't, please don't take that much of variable, just take the names properly. Angle AOB, angle a like ABO, like this. Okay, angle AO, suppose here M is there, so angle AOM, the exterior angle, so form. Just take the name of the angles properly and then you will be able to prove. The logic is clear to all of you.
Yes, ma'am.
Now this question, just this much. Here, just it is given that QR and OQ are equal. Okay, and it is also given that angle PRS is 30. So find angle SOP.
Ma'am, is it 90?
How you got 90?
Ma'am, since it's given OK is equal to QR, angle QRO will be equal to angle QOR. So both of them will be 30. And by
Yeah,
using angle sum of triangle, we will get angle OQR as 60 degrees. Sorry,
yeah.
120 degrees.
Okay, 120, yes. This 60 and that is 120. Yeah.
And then by linear pair, we will get angle PQO as 60 degrees.
Mm.
And since both PO and QO are radius, both of the angles will also be equal. So angle POQ will also be 60 degrees. And to find
This is
SOP,
okay.
we can just subtract 60 plus 30 from 180.
Yeah. Yes, exactly like this we'll be doing. So many things he said in one go. Yes, we will be doing like this. I am coming to it, what he said. Okay, the logic which we are using over here is very basic. So at first we are saying that since since QR and OQ are equal, the opposite angle will also be equal, right? So if this is 30, this will also be 30. Yes or no, everyone? Right? Are you getting it?
Yes, ma'am.
Okay, this will also be 30. And then we are saying that we can find this angle. We are having a triangle where this is 30, this is 30, 30, 30. Then this angle by angle some property will be 120, right? Right? Angle Q will be
Yes,
120.
ma'am.
Then the remaining part of Q here will be 180 minus 120 because basically it is a straight line. Okay, the below one is not look, it doesn't look like a straight line, but in the actual figure you can see. Okay, PQR, it's a straight line. Okay, that's why we are saying the remaining angle over here will be 180 minus 120, that is 60. Now here we can see in this triangle, we can see that OQ and OP are nothing but just the radius of the same circle. Okay, so the opposite angles will also be same, right? So if this angle
Yes,
is
ma'am.
60, this will also be 60, and hence this will also be 60. Equilateral triangle, it will become. Okay, you just found that two angles are same, but by angle sum, the third will also be same. Okay, and then this angle you have to find. So you will say by linear pair, this complete is making 180. Okay, so one of the part is 60, another part is 30, and the another part you have to find. So you will say that question mark plus 60 plus 30 is nothing but 180. Clear? That is 90. Is it clear
Yes,
to
ma'am.
all of you? Now the next question. Just a second, no, let me draw the figure. It's really smaller. Let me draw it properly. Just a second. Okay, yeah, this is the actually just a second. Let me rename it ODAS. Yeah, we have to find angle AOB. There is O. Okay, this is O. Just a second. No? Find X if AOB is 100 and 100 degree. So AOB, this is O. Let's rename this one. This one I'm calling ODAS. Now there is no confusion, right? Right?
Yes, ma'am.
See this one, let's discuss it. Here we need to do one construction. Okay. What we can do over here, if AOB is given, then we can find the remaining angle by linear pair, right?
Yes, ma'am.
We will say this will be 80 degree and we will do one construction by joining B and C. Now can you see triangle BOC? For in a smaller circle, there is a triangle BOC where OC and OB must be equal, right?
Yes, ma'am.
Okay, so one of the angle is 80, so other two angle which will be equal will be 50-50, right?
Yes,
Yeah.
ma'am.
If this is 50, then we can find by linear pair the remaining angle, the remaining complete angle over here. So 180 minus 50, 130, right?
130.
Okay, and there is a property that in a cyclic quadrilateral, does it looks like No, it is not cyclic. No. Okay, it is not at all cyclic because cyclic means all the four vertices must lie on the circle. So, okay, no worries. We will be getting this angle also 130. And there is an arc which is creating angle at the center and angle on the circumference, right?
Yes, ma'am.
Okay, this angle I'm talking about. So this will be double of that, right? It will be 260. Yes or no? Everyone, are
Yes.
you getting it? angle created by an arc on the at the center is double of the angle created by same arc on the circumference. That means on the remaining part of the circle. So if this is 260, we can say x will be 100. Yes or no? Is it clear? Is it clear to all of you?
Yes, ma'am.
Okay, like this we'll be doing. So yeah, I'm keeping this much. Circle chapter, I'm going to activate the assessment. Please go ahead and give the assessment. And homework also I'll be sending after the class. Okay, and then in the next